Good afternoon, everyone. Welcome to Unified Academy. Today, I'm Kumar, in front of you to discuss on the topic of transducer, Unit 6 transducer. Let's start now. Unit 6 transducer. Transducer, introduction to transducer. We will discuss all the topics like introduction to transducer. A transducer is a device that converts one form of energy to the another form of energy, converts the measure to the enable electrical signal. A transducer is a device which converts all the signals into the electrical signals. In other words, it is a device that capable of converting the physical quantity into a proportional electrical quantity, such as a voltage or current. The physical quantity may be mechanical, chemical, optical, or thermal. Transducers are classified based on the applications, method of energy conversion, nature of output signals. Classification of transducer. We will discuss on the topic of classification on transducer. The transducer can be classified as a active and passive transducer, analog and digital transducer on the basis of transaction of principle used. Primary and secondary transducer and inverse transducer, and next one is the electrical transducer, voltage, current, frequency, and their second one is the non-electrical transducer, and displacement transducer and optoelectronics transducer. Active transducer. We will know about the active transducer. These transducers do not need any external source of power of their operation. Therefore, they are also called a self-generating transducer. The active transducer are a self-generating device which operate under the energy conversion principle. As the output of active transducer, we get an equivalent electrical output signal. Example, temperature of a strain to electric potential without any external source of energy being used. Now we will see the diagram of classification of active transducers. In active transducer, there are 6 types. Maybe there is a photovoltaic, thermoelectric, electromagnetic, a piezoelectric, and chemical, and other one. That's. Now we will study about a passive transducer. These transducers need external source of power for their operation, so they are not self-generating types of transducers. A DC power supply or any audio frequency generating used as external power source. These transducers produce the output signals in the form of variation in the resistance, capacitance, inductance, or some other electrical parameter into response to the quantity to be measured. Now we will study about the classification passive transducer. Now we will see about the diagram, theoretical diagram of a passive transducer. Passive transducer have a variable resistance, variable reactance, optoelectronics, half effect type. Now in a variable resistance, there is a strain gauge, thermistor, potentiometric, photoconductor, LDR, and there in a variable resistance there is a 2 types, inductive and capacitive. In a inductive types there is a variable reluctance, variable permeability, and LVDT. And in optoelectronics there is a photoemissives and the photoconductives. Active and passive transducer. Active transducers containing these properties, and in a passive transducer these are the properties of passive transducer. In active transducer, self-generating type, and energy for a generating outputs obtained from physical phenomena, and they all are the thermocouple and piezoelectric transducers, photovoltaic cells, and photoelectric and photomission cells. In a passive transducer like that, there is a externally powered resistance types, strain gauge, and there is a potentiometer device, and thermomisters, and inductive types. In inductive there is LVDT, and capacitive type there is a half effect transducer. Basic requirement of a transducer. In a basic requirements of transducer, there is a linearity, ruggedness, and there is a repeatability environment, and one next is a high extensibility and reliability, and good dynamic response, and convenient instrumentation, and good mechanical characteristics. Now we will discuss about linearity. Like characteristics between input and output is known as a linearity, and regardless the ability to the within overloaded to the protection measures, and availability to the produce same energy, availability to the same energy, and good dynamic response, ability to the change output quickly for a dynamic variation in output with the respect to time. In a good dynamic response, there is a dynamic variation input the respect to time, and conventional instrument high analog output, high SNR, high analog output, and high SNR, and direct measurement or after amplification. Good mechanical characteristics. Last characteristic is the good mechanical characteristics. In this characteristics, there is the ability to withstand the deformation and deterioration of a performance caused by the various mechanical strain. And this topic, resistive transducer. In a resistive transducer are those transducers. Resistive transducer are those transducer in which the resistance change due to the change in the some physical phenomena. And the next is the resistance of a metal conductor is expressed by the simple equation R equal to QL into A, where R is the resistance of the conductor, and L is the length of the conductor in M, and A is the cross sectional area of the conductor in M square, and P is the resistivity of the conductor material in -M. Capacitive transducer. In a capacitive transducer, transducer, the measurement is converted into change in the capacitance, and there is a second the relationship between in the capacitance and the size of the capacitor plate amount of the plate separation, and the dielectric given by the C equal to E naught ER A upon D. And this is a diagram of D is the for displacement area. D is the separation of distance of the plates M, and C is the capacitance F equal to farad, and E naught equal to absolutely permeability and of vacuum, and ER is the relativity permeability, is the effect overlapping area of a capacitor plates. And capacitive transducer, a movable diaphragm one plate of the capacitor. The distance between diaphragm and aesthetic plates change of the force applied to the diaphragm, and the change in the capacitance is measured with an AC bridge circuit or oscillator circuit as change in the frequency. Can we measure both static and dynamic changes? Drawback sensitivity to temperature and variations. And this is a diagram of a capacitive transducer. There is a this layer is known as deflected diaphragm, and this is a static plates, and there is the insulting material and rear capacitive termination and dielectric, and there is a pressure on these devices and under apted diaphragm. And next one is inductive transducer. When a force is applied to the ferromagnetic or armature, the air gap changes, varying the relaxation of the magnetic circuit. And second one is the applied force is the measure as a change of the inductance in the coil, and can measure both static and dynamic changes. And there is a drawback, limited free frequency response. This is a diagram, and there is a meter, and air pops are available in this. And next, thank you for watching the video. That's over. प्लीज बोल देते हो.